for coming, you guys, and good morning. I want to say thank you to Lee Mahavier for inviting me to come speak. I've never been to this conference before, and it's been really enlightening, so I'm enjoying it. The microphone, I'm not used to speaking in microphones, and I don't know if I like it or hate it yet. You know, maybe it seems kind of powerful, a powerful device for students, so I'm going to try and embrace it. But I'm talking this morning about developmental mathematics courses and some techniques I use in the classes I teach at University of Texas San Antonio. Speaking at the roundtable sessions yesterday, I noticed that a lot of universities have different arrangements in terms of the developmental mathematics courses, and so I'm going to focus more on the activities that I do in my classes rather than specifically, I guess, the problems that I face when I teach these classes. Maybe some of the techniques that I use that work. I think that would be more worthwhile at this conference. So student frustrations with developmental math courses, really every student that I talk to says that they're really not interested in math. They're not interested in math. They maybe are getting instructors who have not taught in the classroom before. Maybe they're TAs or graduate assistants, and I think there's maybe a disconnect between the student and the person teaching the class, the instructor. Sometimes, oftentimes. But for teacher frustrations, I can definitely say that we have a broad number of topics to cover. Students that we have are mostly not proficient in basic math procedures, and they come in with a negative attitude towards math. So a lot of barriers and problems that we have to overcome when teaching these courses. So, okay, at my university, these are the topics that I'm required to cover. So I don't know if that's similar to your experiences elsewhere or other universities, but really I think this is an unrealistic request, right? I probably could have done multiple slides for this. I'm sure you can't read all of these, right? So how do we do it? You know, I mean, with all these issues, the student frustrations, they're frustrated coming in, right? With the teachers, we're thinking, okay, well, I have students that don't know math anyway, and then I have all of these topics to cover. So how do you deal with it, right? And here's your question. I really want to stress that I think that we can't to answer this, we can't do the traditional teaching methods, right? We can't cover all of the topics that we're supposed to using traditional teaching methods, being lecture-based and where the students are just passive, right? It has to be active learning. I also think that that we're going to have to use the IBL techniques. Teaching students how to read their textbooks, and using both informal and formal assessments. Okay, so that's kind of how, these are some of the things that I use to deal with the issues. So, I want to start by showing you maybe some lessons that I use in my own classroom. I don't teach topic by topic in terms of like PowerPoint slides, or I don't go section by section. I try and do maybe what's more considered a flipped classroom to some, where the students are reading the textbook outside of class and answering the traditional problems outside of class, coming in and I'm doing more activities with them. For instance, this, Pythagorean theorem. Most students coming into this class, the classes, developmental classes, do not think of area diagrams when they think of Pythagorean theorem, right? They just think of the actual formula a squared plus b squared equals c squared. So one thing I like is that any of these activities that you do with students, it's the first time that they've seen it or they've thought about it, right? So it's really a bonus for us because we kind of become the ambassadors to the subject, right? So this is a chance to show them, okay, make the connections for them. I think it was the speaker yesterday at lunch. He was saying, you know, we have to fill in the gaps, right? With developmental math instruction, it's huge. The gaps are huge. So our job is to fill those in, and one way is to connect the algebra and the geometry for them. So here's an activity that I give them in the class where they can see where the formula comes from. In fact, most of my classes, I try and explain where the formulas come from, or have them, not so much explain, but have them discover where they came from. If you notice in this one, in this activity, the student is asked to write the relationship. And usually they get it, or they see the connection on their own, and there's very little I have to do here. But it's the first time they've really connected areas with algebraic formulas, right? Even formulas as simple as the area of a rectangle or square, right? Most of the students haven't done tilings before, and they don't know where the formula came from. So even activities that seem basic, that's what they're lacking. Okay, most of the times these students have been just told formulas. So I go from something like this to where they're actually, I give them a pictorial proof of the Pythagorean theorem, and I ask them to explain it. Right, so sometimes, like if I gave them this one, I would give them probably scissors so they could cut out the triangles and fill in the center square. But here I usually have students actually explain what they're doing, right? So I'll give this to the class, perhaps in a worksheet. I'll let them work on it for maybe 5 minutes, and then somebody has to come up and explain it. You know, why does it work? Most of the activities that I do are short, they're chunked. So they're probably working in like 5-minute increments on these. Okay, so I put on your tables the scratch cards, right? Scratch cards, so one issue I have in my classes that I teach is I have to take attendance. I have to document who's attending regularly. I have to turn in people who are not attending. It's tedious. It could be tedious if I don't find ways around that, right? So the scratch cards are one method. You often feel as though you're playing the lottery, right, when you're doing these, which is pretty fun, right? So I have the students put their names on the cards. And at the beginning of class, I'll ask questions like this, right? Non-math related, okay? But I want to I think it was Susan. She said yesterday, you may get a sandwich, right? So we start off with something that's pretty easy for them or fun for them to answer, and then we start getting into harder material and then end on a positive note again, right? So go ahead and try this. So on your scratch card, you're going to answer the question, who won the World Series in 2014? And then you can see, really the point of this is so that you can see too, how does it look when you get it right? This not only serves the purpose of attendance for me, but when I get into equations, I can see, when I collect them, right, I can look and see if the students got them right, how many times they tried to get the right answer, right? So I can see, okay, how many are scratched off, right? So it's going to tell me they didn't get it, at all. They're all scratched off. They didn't understand this problem. So these are really great for immediate feedback on how students are understanding. Hopefully you got that one right. Did you get it right? I think it was San Francisco Giants. So I might switch to something like this, right, where, again, we had to discuss the Pythagorean theorem, kind of making the connections between the geometry and the algebra, but then going into a more traditional multiple choice problem, right, that they might see on exams. At my university, I'm given the common final exam, and it's multiple choice. So I don't have a choice in terms of the format of assessment. So I try and give them opportunities to answer in multiple choice. It's not that I prefer that in terms of math learning, it's that that's the type of questions that they're going to see on their final. So I like to prepare them for that. So you should answer this on your scratch card. So the other thing to remember, you guys, is a lot of times, like, we enjoy doing these problems, right, and working out problems. A lot of the students that we have, they have to learn how to enjoy these, you know, so getting them, I would actually have them work in groups to do this. So some people are by yourself at a table. You'd be working together with a partner to answer these. Did anyone get the right answer?
Yes.
Did you? Okay, good. Would you, does it say, it has a check mark, right, when you scratch it off?
A star.
A star, yeah, a star. Okay. So here's another one that I throw in there. To get from his college to his apartment, Leo travels 6 miles east, then 5 miles north. When Serena goes to her apartment from that same college, she travels 10 miles east and 2 miles south. What is the approximate shortest distance between Leo's apartment and Serena's apartment in miles, rounded up? So I'm hoping you're seeing they're going to get progressively harder, right? They're getting progressively harder, but there's still problems that are reasonable for the students coming in to be able to do, right? And I guess that's kind of, we want it to be doable, right, for them. We want it to be encouraging and not a scary experience when you're answering these. Did you get it? Did anyone get it? Did you guys get it? Was it easy? Yeah. It's nice when you get those stars, right? And that's one thing I want to say is that using these, students really like them because it is kind of like playing the lottery, right? And you get that immediate gratification when you see the stars, right? That gives them instant feedback. And again, it gives me feedback in terms of, can they do the problems? How many times did it take them to do the problems? They're working together on it. And also I can use the cards to meet my attendance requirement, right? Okay, this is a question that is on their common final exam. So I guess I wanted to illustrate here that I talked to them more about the connections between geometry and algebra. I like to tell them a little bit about Pythagoras. I try and color the Pythagorean theorem for them more than what they get in a textbook, right? I'm sure I spend more time on that than what the curriculum dictates. Okay. But I still want them to be able to answer the common final question, right? That's still important to me. So the problems that I give them at the beginning of the class help them answer something like this. So that's still important in terms of them successfully completing the class. So, did you get it? You should be doing this one too. Is it easy? Yeah, and the other thing that throws them off, the approximations, rounding, I always tell them to round because that's something that they struggle with, so I try and give them lots of practice rounding. Keep going. Did you get it? Okay. I don't want to steal your glory. I'm gonna keep going. Okay. Hopefully you got, I think it was B, right? Answer choice B? So what does research say? I do a lot of the activities in class, but research tells us that they should be proficient in basic mathematical procedures, right? So what does that mean? I can't stress enough that even though I do activities in class, I still lecture. I still tell them they need to memorize their multiplication facts. I still give them the traditional homework assignments on my math lab. That's still very important. However, I think that in the classroom, doing the activities and making the connections for them between different fields of math is really important. Giving them some background in math, talking to them about the history, the number systems. I do all of that. That's not in the normal curriculum requirements. And Anna Sfard said, to reflect on the processes they perform, students first have to acquire a mastery of the processes, sometimes to the degree of automatization. So I give them lots of homework, and it was Dr. Starbird, I think he said that he didn't give a lot of homework because he didn't like to grade it. Well, I use my math lab, and that grades it for me. But I think for developmental students, homework is really important. I probably give them, when I say a lot, it maybe not a lot to most people, but I probably give them about 30 problems a week in sets of 10 and groups of 10. Usually it takes them about an hour and a half to go through the homework problems because they're actually sitting and having to go through the problems step by step. Would be traditional homework problems, solving equations and so forth. If they have trouble solving them, I will take questions in class, but I try and spend the majority of time either I have them going to the board to explain. I try and get them to explain rather than me talking about the problems, and doing activities. I try and spend the majority of my class time doing that rather than traditional problem solving on the board. Okay, the other thing I use is learning catalytics. And I don't know if anyone's familiar, if you use it in class or not, but to get them to do their homework. So I use learning catalytics in terms of I can make up my own problems about the textbook. So a student would go in, enter a session number, and then I make my own problems regarding what they should read in the textbook. So I'll just take a quick look. 90. This is what the student would do. I could also use this in terms of like clickers in the classroom. And let me see, I think I can do it again. Go back. Yeah, these are going to be like traditional problems, except for I can put in, like there are some free response short answer questions. That's really nice. I have to enter in what I want the students to answer. Like it'll grade it for me, basically. But this is, Learning Catalytics comes with my math lab. So it's, when they purchase the My Math Lab Pearson product, you get Learning Catalytics with it. So I've been trying to use that because I can make my own problems, my own questions, and they're free response questions. The last couple things, I have the students look at other student work. That's been really helpful. They might answer something like this, where I put a problem on and I ask, what's wrong with it? You know, I ask them to look at it and critique it. And then I might answer a harder question, like at the bottom, what is the product of the slopes of perpendicular lines? Can you explain why? Those are some things that our students traditionally haven't thought about. Why is that true? I can go into, I usually use GeoGebra to illustrate those. So I may pose the question. I hope that students can answer it. Usually someone can. If not, I'll assist them with the answer. Other couple things that you need to do for developmental students, build the math community. So I don't remember who it was said to put away cell phones and so forth, right? And be present in the moment. I always stress that with my students. Also making connections, forming study groups. That's really important. And lecture opportunities on and off campus, I always give them extra credit points if they can attend some lectures that are either on campus or off that are math related. And the last thing is, I think Dr. Starbird said that students, one of the things he struggled with was intellectual honesty, right? My students are ones that are never 100% certain of anything. In fact, they're very uncertain. They often ask the question, where do I begin? And so that's kind of what I strive for, is to help them figure out, okay, where do they begin? Where do they start? And to get over the fear of attempting to answer things and to work on problems, right? I just want to get them to be comfortable in the classroom and to be, able to ask how to do things, approach me with how to do things, approach their peers, and figure out, what they need to do with problems. So, but I'm going to stop there. And with that, and I guess if there are any questions.
Maybe one question?
Yeah. No.
Do they have 2 semesters of this math class at your school in their degree program?
Yes, they have 2 semesters. Yeah, exactly 2. Yeah.
Class size?
Anywhere between 30 to 50 students, typically. Yeah, smaller sizes. Assessing, the grading, I stress assessing things. These students won't do work voluntarily, so it does put a large burden on grading, but I think it's worth it.
The math department here at UT, for as long as I've been around, they limited the class size to 40. So typically we'd have upper 20s or 30s, which made it a lot more fun.
Yes.
But now, because of budget crunches, they're going to go more
Larger.
to 50.
Yeah, yeah.
and not offer as many sections.
Yeah. I'll be honest, I enjoy teaching these classes because it's fun to show students that math, really, I don't want them to think of math as just plugging in numbers and solving. I like to show them how to, problem solve, really open up their world for them. So it's really fun.
I'll just say that this is where I learned to use the OR method, is working with these students.
Yeah.
All right, so I'm sure Carolyn is open to continuing the discussion, but we want to give you time to move around if you need to. So let's thank our speaker.